Okay, let's take a look at another problem. Now, this problem is a good example of what happens when all the terms on one side of the equal sign disappear. What you want to do is you want to be mindful that if you don't have any terms on a side of an equal sign, you can always use 0 as a placeholder. So there are no like terms that we can combine on each side, meaning I can't add these together to get one term. So I can skip that first step. And I didn't mention in this process, sometimes you have to apply the distributive property. If you see parentheses, that'll be necessary. So that's not an issue as well. So now I want to move the terms. And now I should move this 8z. The reason why is because it has the smallest coefficient. Let's suppose you just decided to move the 10z. And that's acceptable. Like you can carry out the process using this approach. Let me change the color up to show contrast. So let's say you subtract 10z, you subtract 10z, you get negative 2z plus 6. So the idea I want to show here is that sometimes all the terms on one side or the other of the equal sign disappear. Put a 0 there as a placeholder. It'll help you to keep track of your left and right sides of the equation. All right, let me go back to the beginning. So for this problem, since the coefficient on the left side is smaller, you actually should move that. So we're going to subtract 8z, subtract 8z. Now, this is me showing the work. If you want to just do mental math on this step and just show the result, then I would write 6. I'll be mindful that I am subtracting 8z from both sides. So I would say 6 equals 2z. And then the next step, we're trying to get z by itself. So we're going to isolate the z by dividing by the coefficient of 2. So I would have z equals 3. And this is how the steps or the process will look if you were to show fewer steps. And again, if you're not clear, the only thing I did was I just divided by 2. So when I write this here, this means divide by 2, and then carry out the division. And then you're done.